How BLDC fans work. This document explores the functioning of brushless DC, BLDC, fans, a popular choice for various applications due to their efficiency and reliability. BLDC fans utilize a brushless motor design that eliminates the need for brushes, resulting in reduced wear and tear, lower maintenance, and improved performance. This document will delve into the components, operation principles, and advantages of BLDC fans, providing a comprehensive understanding of their mechanics. Components of BLDC fans. Stator, the stationary part of the motor, typically made up of coils of wire that create a magnetic field when electricity flows through them. Rotor, the rotating part of the motor, which contains permanent magnets. The rotor spins within the magnetic field generated by the stator. Electronic speed controller, escape, a crucial component that regulates the power supplied to the motor, controlling the speed and direction of the fan. Hall effect sensors, these sensors detect the position of the rotor and provide feedback to the escape, ensuring that the motor operates efficiently. How BLDC fans operate. The operation of a BLDC fan can be broken down into several key steps. Power supply. When the fan is powered on, electricity flows to the escape, which converts the input voltage into a suitable form for the motor. Magnetic field creation. The escape energizes the stator coils in a specific sequence, creating a rotating magnetic field. Rotor movement. The permanent magnets on the rotor are attracted and repelled by the rotating magnetic field, causing the rotor to spin. Speed control. The escape adjusts the timing and duration of the current supplied to the stator coils based on feedback from the Hall effect sensors, allowing for precise control of the fan speed. Cooling effect. As the rotor spins, the blades attached to it create airflow, providing the cooling effect that fans are designed for. Advantages of BLDC fans. Energy efficiency. BLDC fans consume less power compared to traditional AC fans, making them more energy efficient and cost-effective in the long run. Low noise operation. The absence of brushes reduces friction, resulting in quieter operation. Longer lifespan. With fewer moving parts and no brushes to wear out, BLDC fans typically have a longer operational life. Better speed control. The electronic speed control allows for smooth and precise adjustments in fan speed, enhancing user comfort. Compact design. BLDC motors are generally smaller and lighter than their brushed counterparts, allowing for more flexible design options. Conclusion. BLDC fans represent a significant advancement in fan technology, combining efficiency, durability, and performance. Understanding how these fans work provides insight into their growing popularity in various applications, from residential cooling to industrial ventilation. As technology continues to evolve, BLDC fans are likely to play an increasingly important role in energy-efficient solutions.